to routing, we can use static routing in order to route traffic between two routers. I want to show you how we can use IP service level agreements to add some reliability to that. Then I also want to show you what it looks like if you don't use IP SLAs and you only use static routing by itself. So we have two routers. We got R1 and we got R2. They're connected over two links. They have a gig link, they have a serial link. This is the IP address of router 1's gig link. This is the IP of his serial link. And this is the IP of his loopback. And on R2, this is the IP of his gig link, IP of his serial link, and the IP of his loopback. Now, if we want to be able to ping between the two loopbacks, we got to have routing in place. I just so happen to be using static routing. So if I come on over to router 1, if I do a show run pipe include route, and I spelled route incorrectly, let's get rid of the W, you're going to see that I have two static routes configured. This static route right here is pointing to the next hop IP of router 2's gig link. This static route right here is using the next hop IP of router 2's serial link. Now he has an AD of 3, and then this static route has an AD of 2. So of course the router is going to choose the one with the lowest AD, so he's going to use this one, which is the static route pointing to the gig link. So if we do a show IP route for router 2's loopback, we can see that the distance is 2 and this is the next hop. So we're using the primary static route. If we do a show IP ceph for router 2's loopback, we can see here's our next hop and we're routing out of the gig link. So this is your typical floating static route solution. What I want to do now is show you how we can configure an IP SLA to add a little reliability to this. Let's first go into global configuration mode. To configure an IP SLA, you simply type IP SLA and then you give it a number. Okay, you see we got a whole bunch of options that we can choose. Let's just say I want to create SLA number 1. Now if I hit question mark, we got a lot of different operations we can use for this IP SLA. The one we want is the echo operation for ICMP. What this will do is tell the router every so often we want you to send ICMP echo requests to a particular destination. And as long as you get a response back within a specific time frame, the IP SLA is satisfied. But if you do not get a response back, well, the IP SLA has failed. So let's do ICMP echo. And now we have to put the IP that we want router 1 to ping, which is going to be the IP address of router 2's gig link. We can also do source IP, specifying what IP address we want to use as a source address in these echo request packets. Let's just make it the IP address of router 1's gig link. Right now we hit question mark, we get a couple of options. We want to use the frequency command. What this does is tell router 1 how often do we want him to send these echo requests to this destination. Let's do frequency, and then we have to put a value in terms of seconds. So every so often, whatever number we put right here, router 1 is going to send these requests. Let's just say we want to do it every 10 seconds. So we say frequency 10. We can also put a timeout value. The timeout value tells the router, R1 in this case, if you do not get a response back by whatever the timeout value is, then the IP SLA has failed. So we can put time out, and then we put a value in terms of milliseconds. Now, just a key math thing for you guys, 1 second equals 1,000 milliseconds. So let's just say we want the timeout value to be 6 seconds. That's 6,000 milliseconds. That's what we're going to put right there. So let's do a quick show command. Let's do a do show run pipe begin SLA. So you can see the configuration. So we have our IP SLA configured. It's an ICMP echo operation. This is the IP address we're trying to ping. We're going to do it every 10 seconds. And if we do not get a response back within 6,000 milliseconds or 6 seconds, the IP SLA is going to fail. Now once the IP SLA is configured, now you have to start it. You do that by saying IP SLA schedule. You then put the IP SLA number you just created, which is 1. You then type start time, and then you have to put the time you want it to start. You can have it start at a particular time, after a certain time, or what we're going to do, we're going to start it now. Okay. Once you do that, now you have to put the lifetime. How long do you want this particular IP SLA to last? You have two options. You can have it last a certain amount of seconds, so maybe 10 seconds, right? Certain amount of minutes, certain amount of hours. It's completely up to you. Or you can do what I'm going to do and make it last forever in my Keith Sweat voice. So let's just say forever. There we go. So let's do a show run pipe include SLA again so you can see the full configuration. All right, and not include SLA. Let's say begin SLA. There we go. So we say IP SLA 1. It's an ICMP echo operation. We're trying to ping this IP, so we're trying to test reachability to this IP. We're going to send this echo request every 10 seconds. We need a response back within 6 seconds. Otherwise, the IP SLA is not satisfied. And then this is the command right here to start the SLA. Okay, so if we do a show IP SLA summary, we see our IP SLA that we created. Number 1, it's an ICMP echo operation. This is the IP address we're trying to ping. It was sent or last ran 7 seconds ago, and the return code is OK. This means that we sent an echo request to this IP. We got a response back before the timeout value expired. So everything is great. So we got the IP SLA configured. Now we have to configure a track. A track is simply an object that's going to track this SLA. And how it works is, as long as the SLA is up, then the track is up. But the minute the SLA fails and goes down, well, your track is going to go down as well. So to do this, we go back into global configuration mode. We say track, and then we give it a number. Okay, you can see we can have up to 1,000. Let's just say track 1. We then say IP SLA, and then we put the SLA number that we're trying to track, which in our example is 1. And there we go. And one thing I forgot to do is put reachability. There we go. So now if I do a show track 1, this is a reachability. So we're basically tracking the reachability of this SLA, and reachability is up. Right? Last operation return code is OK. So again, as long as the IP SLA is up, your track is going to be up. So reachability is up, return code OK. Now once you create the track, now you have to apply the track to your static route. And if we do a show run pipe include route, the static route that we want to apply the track to is the one we're using as the primary, which is this one. Okay, this is the one we want to prefer because we gave it a lower AD. So this is the one we're going to apply the track to. So let's come into global configuration mode. We're going to copy this, right? And we're going to put track right here, track, and then we put the object we just created, which was 1. Now when I do my show run pipe include route again, you're going to notice it puts an extra static route right here. Okay, we no longer need this one. So I can get rid of this one, and then we'll just have the primary with the track and then our backup. So let's go into global configuration mode. Let's type no, and let's get rid of this one because we don't need that one anymore. Right? And let's hit our up arrow key a couple of times, and we should just have 2 static routes. Okay, the primary static route has this track. secondary static route does not. So now that we have the track in place, let's kind of see what happens now if we experience a failure. So here's what happens. Okay, as long as the IP SLA is up, the track is up. As long as the track is up, you can use this static route. Okay, the router can use it. But the minute the IP SLA goes down, the track is going to go down. And if the track goes down, whatever static route is tied to that track cannot be used. So this static route right here, no longer usable. So to simulate this, what we're going to do is come over to router 2, and we are going to shut his gig link down. And before I do that, let me do a ping to his loopback, sourcing it from my loopback. Let's just make sure we have connectivity. And we do. So let's come over to router 2 and let's shut his interface down. So now that his interface is shut down, this ICMP or this IP SLA should eventually fail. So we do show IP SLA Summary. You see right here we have a return code of timeout because we sent an echo request to this IP. He's no longer responding, so we get timeout. Notice now the track went from up to down. If we do show track 1, notice now return code timeout, reachability is down. So if the track is down, that means the static route that is tied to that track can no longer be used, which is this one. So since he can no longer use the static route, what we should see is router 1 delete this static route out of the table and plug in this static route. So we do a show IP route for router 2's loopback. Notice now we see a distance of 3. Notice now we see the IP of router 2's serial link as the next hop. And if we do a show IP ceph for router 2's loopback, we're now going over the serial link in order to get to 2's loopback. And if we ping router 2's loopback again, sourcing it from our own loopback, we still have connectivity. Okay. Now what I'm going to do to kind of show you why we use IP SLAs, I'm going to bring back up this gig link. Let's do a no shut. All right. What should happen is the IP SLA is going to be met again. So we do show IP SLA summary. It says okay again. We do a show track 1. He's back up, which means that primary static route should be used again. Okay, so now we have a distance of 2. We're going back to the IP of router 2's gig link. Do a show IP ceph for router 2's loopback. We're going back over the gig link. Okay, now what I'm gonna do, let's do a show run pipe include route. I am going to get rid of this static route and I'm gonna put it back without the track. Okay, so let's hit our up arrow key. Let's do a no, and then let's get rid of the track and just have a regular IP static route. All right, so let's do a show run pipe include route. Okay, so we have our primary again with no track. Then we have the standby, the secondary route. What I'm gonna do is come back over to router 2. I'm gonna come back to this gig link and I'm gonna shut it back down. But before we do that, let's come back to router 1. Let's just do a ping just to make sure we got connectivity right now. And we do. Everything is great. Let's shut this link down and see what happens. So we're gonna shut it down. All right, so he's shut down now. And if I do my ping again, we see that the pings are failing. So we shut down router 2's gig link. Router 1 can no longer ping the loopback of router 2. Okay, let's do it again. And it's still failing. I want to show you why. So we come over to router 2. let's do a show IP route for router 1's loopback. Okay, we see a distance of 3. So when we shut the gig link down on 2, to remove the static route going over the gig link, and he put the static route going over the serial link. Okay, we can verify this because if we do a show IP ceph for router 1's loopback, 2 is trying to send the traffic over the serial link. But if we come back over to 1, let's just do our ping again. You see it's still not working. Okay, even though 2 deleted the static route going over the gig link, put the static route going over the serial link, 1 still can't ping 2's loopback. Let's do a show IP route for router 2's loopback. I see a distance of 2, right? Distance of 2 means we're using the primary static route. And I see that the next hop is the IP address of router 2's gig link, which we just shut down. And if I do a show IP ceph for router 2's gig link or router 2's loopback, notice that router 1 is still trying to route traffic out of his gig link. All right, and here's why. Here's why. Let me do a show run again, pipe include route. I want you to understand this. So router 1 has 2 static routes, okay? The only way, or what, I won't say the only way, but by default, router 1 is going to believe that these static routes can be used as long as he can find an outgoing interface to these next hops. So you got your primary static route right here. As long as router 1 can find the outgoing interface to this next hop, he's going to deem this static route as being usable. So if I do a show IP ceph for the next hop, notice it says it's attached to gig 0/0, right? And that's because if we do a show interface gig 0/0, his interface is currently up. So as long as his gig link is up and he can find the outgoing interface to this next hop right here, 1 is going to keep trying to send traffic out of his gig link to this next hop. The problem is we just shut that interface down on router 2. So we do a show IP interface brief. This interface is shut down. So right now, 1 is trying to route traffic to a next hop he does not have reachability to. See, if we do a ping to router 2's IP, it's failing. So essentially, router 1, when he tries to send traffic to router 2's loopback, when he sends it out the gig link, he's just sending it straight into a black hole. It's not going to go nowhere because 2's interface is shut down. So this is why we use IP SLAs, because in the real world you can run into a problem where one side is up, the other side is down, and as long as router 1 thinks his gig interface is up and he can find an outgoing interface to that next hop, he is not going to fail over to the secondary, which is the one going over the serial. So this is why we have the IP SLA, because now we're telling router 1, look, don't make your judgment based off the status of this interface. Don't do that, right? Because you can be up, but the other side can be down. Instead, I want you to ping this IP. If you can ping him, great. Use the static route going over the gig link all day. If you cannot, there's no reason for you to use that static route because you can't get to this next hop. So delete that static route. Don't use it and use the backup. So now, if I come back, I'm going to apply the track back. So I'm going to say that, and then I'm going to get rid of this static route. So we do a show run, include route. You'll see where I put the track back on right here. So now the static route is tied to the track. But if we do a show track 1, it's down. Since the track is down, this static route cannot be used. So now if I do a show IP route for router 2, now he's using the backup. Without this track, he still would have been using the primary and our pings will not be working. But now we got the track back on. We do the ping, it's working again. Ladies and gentlemen, that is IP SLAs.